The cooling principle of air conditioners is based on the thermodynamic principles in physics. It involves 3 steps for the refrigerant in the pipeline: compression, condensation, and evaporation, forming a cycle process of heat exchange from the indoor to the outdoor. The compressor compresses the low-temperature gas transferred from the indoor into a high-temperature and high-pressure gas at 80 degrees Celsius. Then, the high-temperature and high-pressure gas passes through the pipeline to the condenser outside. At this time, a large temperature difference is formed between the 80 degrees Celsius high-temperature gas in the pipeline and the normal temperature of less than 40 degrees Celsius outside the condenser. Then, with the high-speed cooling of the large fan of the condenser, the high-temperature gas suddenly loses heat and condenses into a liquid. Then it passes through the expansion valve. Inside the expansion valve, there is a very narrow area. After the refrigerant passes through the narrow area, the pressure is released and the temperature drops sharply. The expansion valve realizes temperature regulation by controlling the flow rate of the refrigerant. The refrigerant that is cooled again through the expansion valve has reached below 0 degrees Celsius and then passes through the pipeline to the evaporator in the room. The so-called evaporator is actually a row of copper pipes followed by an impeller fan. When the flowing air comes into contact with the copper pipes, the heat in the air is absorbed by the low-temperature copper pipes, so the wind blown out is cold. The refrigerant coming out of the evaporator pipeline is then transported to the compressor for compression, forming a cooling cycle of heat exchange between the outdoor condenser and the indoor evaporator.